This question definitely takes a little bit of creative problem solving, but if you follow their parameters, you should be able to make the data work so that you can achieve the goal and get the right answer. So, what is the goal that we're looking for here? Based on these two sets of data, we're trying to find the smallest possible difference between the mean of one of them and the mean of the other. So, if we can try to make these data sets as similar to one another as possible, then it would follow that their means would be as similar to one another as possible. And sorry, that's my cat. So here, what do we have? So if we compare data A and data set A and data set B, data set A is looking like it's a little bit larger in terms of the values of the integers than data set B would be. So just to be clear as to what each of these histogram bars represent, the first interval is actually going to be equal or greater than 10, but actually less than 20. So in other words, this first bar will include the bottom bound 20, but will not include the upper bound 30. So the biggest number that you can get here would be 29, and so on and so forth. And then same thing here, the smallest number you could get here is 10, the largest would be 19. Okay, so thinking from that perspective, how can we make these two data sets as close to each other as possible? Because data set A is farther along in terms of value to the right, we would actually want to shift that to the left as much as possible, and vice versa for data set B. So what would be the biggest number that we could make this bar represent? So if we said 19, that would be correct. And then similarly, this one could be 29, this could be 39, and this could be 49. And then over here, we want these to be as small as possible. So this one could be 20, this one could be 30, this one could be 40, and this one could be 50. So now, if you kind of look closely at what these data sets end up being, they're only off by 1. And so their means are just going to be off by 1 as